setting up the environment. You should be familiar with this graph. Although this specific image was not in the slides, in the theoretical part, there was something very similar. I'm gonna go through it so that you understand what I mean when we move on to the code. The environment that we want to set up is this little part at the bottom. It's the environment the agent is evolving in. So the agent is going to take an action and then the environment is going to be affected by this action that the agent took. So what we want is to code an object or a class, more specifically, that can take in an action from an agent and given a certain state is going to move to the next state and provide a reward that could be either positive or negative, and that's going to depend on the quality of the action taken by the agent. This is the part that we want to code. Before I show you the code for this specific environment, I want to talk about OpenAI Gym environments. They're very often used as learning tools in reinforcement learning, and you can access them by installing the Gym library in Python. It contains a myriad of game environments that you can test RL agents on. So what I'm going to do is click on the link provided in the notebook. It's going to take you to this page. This is the documentation of the Gym library. We're not going to use this library today, but I did use the same principles to build the environment class. And it could be interesting for you to have a look at it and understand the basic principles. This is one example of a gym environment. It's called the cart pole and it's used time and time and again. It's a game where the agent has to learn to balance a pole on a little cart. So it has to learn to simply move right or left in order to make sure that the pole stays balanced and does not fall down. I'm not going to go into too many details with the Gym library, but I just wanted to introduce it in case you didn't know about it. Now we're going to go back to the notebook. Our environment class is going to have a series of methods. 2 of them are really important. They're all important, but 2 of them are actually inspired by the Gym library. The step method and the reset method. So the step method is going to take as input the action and output the new state and the reward. So basically it's the arrows that you see here. The environment takes in the action and outputs the reward and the new state. The second method, the reset method, does not take any input, but it does output the initial state. So the reset is sort of the first method that we call before we start playing a game to train the agent. If you scroll down, you're going to see that the next part defines the state. This state definition was actually taken from an article. I'm going to click on the link. It's provided here in the notebook. The name of the article is Asset Allocation Using Reinforcement Learning. I'm just going to scroll down and show you the table of contents. The state definition is specifically defined in the methodology and proposed extensions in the reinforce evaluation section. I'm not going to show you extensively the content of this article, but I just wanted to show you where you can find, if you want to read it and find out more. A lot of the content in the notebook is actually provided from this specific article. Going back to our notebook, we're ready to have a look at the code. First things first, we're going to import the libraries that are needed to code the environment class. We're going to need NumPy, Pandas, and the random library. I'm just going to go ahead and run this coding cell. I'm going to do the same thing for the next one that contains the environment class. And then I'm going to explain in the same order that it's coded in the notebook. So the first thing is the init method. When we instantiate the environment class, or the env class in this case, the first thing that is done is it's going to run or compute the init function. There are two contexts that are possible, the train and the testing context. So in the context variable that we see here, if we specify train or test, it's going to upload into the returns variable the adequate data sets. So if we're in a training mode or in a training context, it's going to upload the training data. Similarly, if we're in a testing context, it's going to upload the testing data. Everything else in this init function is basically just creating an instance of the variables that we're going to need. So I'm going to go in order: the number of assets, the number of actions, which is the same thing as the number of assets, the time step at which we are in the episode, the total number of steps in one episode, the look back window. Remember that this variable is essential to define the state appropriately, the history length, and these two are not of your concern. Then the last thing we do in the init function is resetting the environment. This is making sure that we're ready to start playing an episode. We always need to run the reset method before playing or generating one episode. Speaking of the reset method, let's have a look at what it does specifically. So as we said, the reset function is used to reset the environment at its initial state. The initial state is going to be randomized. So what the function is going to do is going to reset any tracker values to 0, as well as initial asset, portfolio, and index values to 1. The first couple of lines of code are necessary to randomize the start of the episode. By randomize, what we mean is every time we play an episode that is going to be used to train the agent, imagine we have a length of a couple of years. Okay, the data is sequential, but every episode is going to have a random start. Maybe sometimes the episode is going to start on the 1st of January of 2006, but sometimes it might start on September 9 of 2017. We're doing this to make sure that the agent does not overfit to a specific time period. The next couple of lines are just the instantiation or the initial state of the necessary variables that we need. So the tracker step, the first step is always 0. The previous action is 0, but this is going to be changed very quickly as we start playing an episode. The portfolio values is at 1 because we want to normalize it. It's going to make it easier for us to compare the performances. As we're playing an episode and we're training the agent, we're also going to want to compare how it's doing relative to a balanced portfolio. So we're also creating a portfolio value for the balanced version. And then we're just saving up the dates. A lot of these variables are not necessary to code the environment variable, but they're useful if we want to understand what's going on. So we're saving up the asset values at the same time, and we're saving up the dates of every episode. That could be useful along the way. Then we're just creating some logging lists to make sure that at every time step, we're saving up the portfolio returns, the index returns. We're doing this because, again, if something goes wrong, there's a bug, at least we're saving the value somewhere and we can dig deeper and understand what's going on. And this is the initial state. That is very important, is where exactly are we beginning our episode. So self.assets is actually the returns of the assets for the initial state. And then here we're defining the state. So all of the lines that you see here are necessary to make sure that we have the state as defined in the article that I showed you earlier. So these lines here are making sure that we have a state that looks, I'm just going up to show you the matrix, are necessary to make sure that we have this state defined here. I'm gonna scroll back because there's one additional step that is essential and it might be confusing, so I want to shed a little bit of light on this. So at this point, this line here, we have this state defined as the equation that I just showed you. But then what we're doing here is we're calling on this state the flatten method. What flatten does is it takes a matrix and is going to flatten it, so it's going to become a vector. Why are we doing this? We're doing this because the policy network that we're going to code in a couple of minutes is going to be a fully connected network. So it's a standard multi-layer perceptron, and standard multi-layer perceptron cannot take in a matrix. It can take in a matrix, but it has to be flattened. So this is why we're first making sure that we have a nice matrix as defined earlier in the equation, but then we need to make it into a vector so that we can actually feed it into our policy network. And then the reset function returns the state. The goal of this use case is to maximize the total returns of a portfolio. So we're training an agent to learn to maximize the returns. We could change this objective. It could be something else, like following an index, for example. This is why in the notebook you see a lot of variables referring to a target return or an index return. And here we have a method called step index. For the first objective that we're addressing in this notebook, you don't need the step index. In the exercises, it's something that I'm going to ask you to do if you want to push the envelope and expand your knowledge and your practice of reinforcement learning. But for now, we don't need to cover the step index. So we're going to talk about the step assets function. Like the name says, once we initialize the episode, we're starting at a certain point in the history. But every single time the agent makes an action, the action goes back to the environment engine, and then the next state is outputted. So that means that we need, if we were at time t0 for the asset value, we need to step to t+1. So this is what the step assets method is doing. Similarly, for the step state, it's taking in as input the action, and it's going to output the next state. More precisely, the first thing we do is we define the state as per the equation that was defined earlier. Those are the lines that you see here. So we have the first column that is going to be the previous weights or the previous portfolio allocation. And then the remaining columns are actually the past asset returns. Then the last two lines, what we're doing is we're concatenating or aggregating the asset allocation with the past returns. And then again, we're flattening the state because the policy network takes in only a vector as input. Moving on, a method that is absolutely essential in the environment is the computation of the reward. Every single time the agent takes an action and it goes back to the environment engine, we need to give it a reward to let him know how good or how bad the action was. So as you can see, this is perhaps one of the most important method in the environment. The reward is simply the log return of the portfolio. That makes sense because we want to maximize the total return. So the more positive the return is, the better it is, and the more negative the return is, the worse it is. And so the reward is adjusted in terms of the portfolio return that the agent was able to generate. Then this little variable called done is simply letting us know if the episode is still ongoing or if we've reached the end of the episode. In this specific notebook, the number of time steps that we fixed it to is 90 days. So the agent is going to have 90 days to accomplish the goal, so to maximize the returns. And so once we reach 90 days, the episode is done. And this is what the done variable is used for. Last but not least, we have the step function or the step method. Again, this is inspired by the OpenAI gym environments, the gym library that I showed you earlier. This function takes in as input action and returns the state, the rewards, and whether the episode is done or not. It's going to do a couple of things. It's going to step the index. Again, for this specific use case, we do not need the index. This is for the exercise section. Then we step the assets. So we're moving one step ahead and then we're computing the return of the portfolio. So we did an action, or the agent made an action, and given the returns of the asset, how good is the return portfolio? So this is what we're doing here. We're computing the portfolio return based on the action that was taken by the agent. And then we're just updating the portfolio value from the beginning of the episode. And we're doing the same thing for the balanced version of the portfolio. So notice here in this last line that we're not using the action that was taken by the agent. We're just simply averaging all of the assets returns. And this is our balanced portfolio. And throughout the training, we're always going to be comparing the portfolio value from the agent and the balanced version. We want the agent to do better than a balanced portfolio. And then we get the new state by stepping the state, and we get the reward. And this is what we return from the step function. We return the state, the reward, and whether the episode is done or if we keep going.